Hi there, this is Mrs McTaggart. In this video we're going to look at National 5 Scientific Notation past paper questions. So scientific notation is a topic you should have learned in S1 or S2. It is technically, it is National 4 or Level 4 difficulty. The problem is with National 5 is they start putting it into context and the language and the understanding of what they're actually asking gets a bit tricky. So before I start, I just need to remind you that you are allowed a calculator for these questions and you need to be aware of what buttons you're using. So if you are using this older style calculator, the button you're interested in is located down here, and it is this one that says EXP, exponential. So that's kind of like your power button. And what that button does is it acts as the times 10 to whatever power you need. So if you were having to do 5 times 10 to the power 6, you would press 5. You would then press this EXP button, and then you would press the number 6. And then if you pressed equals, it would come out the number 5 million. If you are using a newer style Casio, there's one like this or one with a blue circle in the middle, they both have the times 10 to the power X button clearly on show down the bottom here. So you'll be using that button. And similarly again, if you needed to do 5 times 10 to the power 6, you will be using that button. And instead of having to do times 10 to the power, you'll do 5, that button, 6. Alright, so the only difference is that wee bit. Now, other buttons you will be needing to use here for scientific notation is you might need to know your negative button as well. If you're putting in a negative power, you can also just use the minus to count as your negative power as well if you need to. So these are all the buttons we're going to be using. So when I'm talking about my working for typing these in, I will just say 5, that button, 6. Alright, because the button is different on each, but that's the buttons I will be using. So it'll either be EXP or times 10 to the power. Okay, so let's get into some examples, and I'm literally going to work through the past papers in reverse. Okay, so I'm literally going to work in reverse order from 2021 backwards for a couple of years. So this was a question last year. Light travels at this speed per second. A star is this distance away from Earth. We have to calculate the number of seconds it takes for the light from this star to reach Earth. So you're asking you for number of seconds, which means it's a speed, distance, time question. So I'm just going to write down some info. I know my speed is 3 times 10 to the power 8. I know my distance is 4.2 times 10 to the power 17. And I want to know my time. So the formula for time, we have to remind ourselves of the triangle, the speed, distance, time triangle. And if you're working out time, then you're left with d over s. So time equals d over s. My distance is 4.2 times 10 to the 17 divided by 3 times 10 to the 8. Now there's two options on how to type this into a calculator. If your calculator has the fraction button on the mode that when you press it like that, you can just type it in as it appears. Or you could just put a divide sign in the middle. The way I'm going to type it in is I type it in as 4.2, the button, so whether you're using the times 10 power or the EXP button, I do 4.2, the button 17, divided by 3, the button 8, alright? And it gives you this here, so it gives me 14 with 3, 6, 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8 zeros, alright? Now, the question said to give your answer into scientific notation, so the one last thing I need to do is write it as 1.4, so decimal point after the first digit, times 10, and the power is how many places it is moved from here to here, and if you remember I said it had 8 zeros, so that means it's got 9 places to go. So my final answer is 1.4 times 10 to the power 9. So that was last year's question. I think that's been a fair one in terms of some of the ones I've asked recently. Speed, distance, time should be familiar from previous years. Okay, back to 2019. So the last time we had an exam before COVID. This one here. It told you that a sesame seed weighs this teeny tiny number. I'm not going to say the number out loud. The 3.6 thing. And times 10 to the power minus 6 means it's absolutely tiny. So the weight of a sesame seed is this. The weight of a poppy seed is 8% of a sesame seed. So they want to know the weight of a poppy seed. So if a poppy seed is 8% of a sesame, what we have to find basically is 8% of the sesame. So it's 8% of this number. Now, the quick way to find 8% is convert it into decimal. So I'm literally going to type in 0.8 times 3.6, the button, and then I'm going to have to put a wee negative in, okay? So you're going to do 3.6, the button, minus 6. So let's type that in and see what we get. And I get... Now my calculator's already put it into scientific notation for me, which is fabulous. It's told me that it is 2.88 times 10 to the negative 6. So be aware, question always wants it into scientific notation. If your calculator doesn't do it for you, you maybe have to do a wee bit of working. So your calculator might come up with 0.123452888, and you have to convert it back to scientific. Okay, it just depends on how big or small the number is, whether your calculator does it and what mode you've got your calculator on. So that was 2019, a simple percentage of an amount. 2018 was really, really badly done because they mixed scientific notation with your reverse percentage question. But everyone in the exam that year just went, oh, they want the volume of the Earth, it's a sphere, and started trying to find the volume of the sphere, thinking this number was your radius or something like that, which got them absolutely nothing. And it was heartbreaking to see because they already had a volume question somewhere in the paper. So they won't give you a repeated skill. They won't ask you volume twice, and you should be looking for a reverse percentage somewhere in paper 1 or paper 2. So let's read the question. Venus and Earth are 2 planets in our solar system. The volume of Venus is this number, 9.3 whatever, cubic kilometres. This is 85% of the volume of the Earth. So we can see that the Earth is bigger, and it's saying Venus is 85% of Earth. Okay? Calculate the volume of Earth. So my starting line is 85% equals 9.3 times 10 to the power 11. The volume of Earth would be us getting to 100%. So this is our aim. Now in between, we're probably going to, remember, go find 1%. So our sum is 9.3 times 10 to the power 11 divided by 85. And then to get that answer into 100%, we get our answer and times it by 100. Now it's whether you want to do this in 2 steps or all in 1 step. If I type in 9.3, my times 10 to the power button, and I divide by 85, I get a horrendous looking number, which I then times by 100. So what I'm just going to do is I'm going to cheat, and I'm going to write that here I do my answer times 100 because I'm not writing it down. And I get this number out, and I'm going to show you. So we get 1.09411 and so on times 10 to the power 12. Now there's no need to write the whole thing out. The question does not specify rounding either. So what I would do is I would always do 2 decimal places. That's my rule of thumb for everything. So I would then shorten this down and say that it is 1.09 times 10 to the power 12. And I'm just going to say that I'm doing that to 2 decimal places. Okay, so remember we were expecting the Earth to be a little bit bigger. Power 12 is a little bit bigger than power 11. So as I said, please be aware they're being very sneaky and creative and mixing scientific notation into other topics. So in 2017 we had this one. And it became very apparent when we were marking this one. A lot of people did the sum back to front. And a lot of people didn't know how many millilitres were in a litre. So we are told there is this number, 3 times 10 to the power 5 platelets per millilitre of blood. On average, a person has 5.5 litres of blood. Then it says on average, how many platelets does a person have in their blood? So I know that 1 platelet, 1 millilitre, I know that 1 millilitre has this number of platelets. We want to know what the human body has. Now, the human body is 5.5 litres. Now, I'm going to change that into mils, which is 5,500 mils. That is what we are trying to find out. Now, if you're going from 1 mil to 5,500, you're timesing by 5,500. So the sum we had to do this question was 3 times 10 to the power 5 times 5,500. So to type that in, we just go to a calculator. I mean, you could even do 3 with 5 zeros if you don't like using the scientific notation button. So we do 3, the button 5 times 5,500, and we get this. Now my calculator didn't put it into scientific for me, so I'm going to write it out. So I've got 165 with 2, 4, 6, 7 zeros. So 1, 2, there's 4, 5, 6, 7. So I had this number there. Now into scientific notation, that would be 1.65 times 10, and I'm moving it 3, 6, 9 places. So this is the answer I was looking for. So this one tests a wee bit of unit conversion as well, and basically a little bit of proportion. The trick is reading the question, try and take the numbers out for a minute and just think of what the scenario is. There's this amount of platelets in a milliliter. A person has 5,000 millilitres, so we're doing the platelets times the 5,500 mils. Okay, we're now at 2016. We're talking about pollen. So a pollen sample weighs 12 grams and it contains this huge number of pollen grains. We have to calculate the one pollen grain in grams and give our answer into scientific notation. So let's think, what have they told us? They've told us that this number of pollen grains is worth 12 grams. We have to work out what one pollen grain is worth. So I'm going from this really big number to 1. So I am dividing by this really big number. So the sum is 12 divided by 1.5 times 10 to the power 9. So I'm going to go to my calculator and do 12 divided by 1.5, the button 9. And it gives it into scientific notation already for me, which is 8 times 10 to the power 9. So it's saying that a pollen grain is this teeny 9 number, 0.808 basically. Now, the year of this question, a lot of people did it back to front and they did the scientific notation number divided by 12. So they were actually working out what 1 gram was rather than one pollen grain. So just watch your wording and sometimes just try and think, like, write down in short what they've told us. And that's what I did there. So I said they've told us that this big number of grains is 12 grams. We need 1 grain. So proportion sneaks in here a lot. Another S2 topic. Okay, we're now back at 2015. This year they thought, let's make it 5 marks instead of 2. The reason being is they combined it with a volume question again, and I think people who'd done past papers had confused this with the Venus and Earth one in the later years, and they jumped in and thought they're asking for volume again. So they've told us that the Earth is approximately spherical with a radius of 6,400 kilometres. We have to calculate the volume of Earth and we have to give an answer in scientific notation to 2 sig fig. So I'm just going to split this up and then worry about part B in a wee second. So question 1. We want the volume of a sphere basically. So we go to our formula sheet and we write down V equals 4/3 pi r cubed. We then replace our radius with what they've told us. So the radius is 6,400 cubed. And you go type that into your calculator. So we're not having to use the scientific notation button at all. And we get this. We get 1.098066. Now this number looks a wee bit familiar from that previous example. So they're using the true numbers because I've literally just had that number before when we were working out the volume of the Earth. Now I've written out the full number, but remember they want 2 significant figures. So whereas previously I said, oh, they hadn't mentioned rounding, so I just do automatic 2 decimal places, to 2 significant figures, well, my first significant figure is the 1, the second significant figure is the 0. So to 2 significant figures, this is actually going to end up being 1 decimal place. So this would round to 1.1 times 10 to the power 12, and it would be cubic kilometres. So let's just write cubic kilometres like that. All right, so that was part A. Now I need to remember this answer for part B. So I'm just going to write down that an Earth was 1.1 times 10 to the power 12 cubic kilometres. We're going to use our rounded answer. So it says the approximate volume of the moon is 2.2 times 10 to the 10. So we can see the moon's a bit smaller. They're saying calculate how many times the Earth volume is greater than the moon's. So we have to see how many times the moon goes into the Earth, right? So moon into the Earth means we're doing Earth divided by moon. So we're doing the Earth volume divided by the moon's volume. So we do need to use our scientific notation button this time. So remember the typing in would be 1.1, that button 12, divided by 2.2, that button 10. And if you type that in, I get the answer of 50. So they've led us in, they wanted us to use the rounded answer and it got exactly 50. So there was an extra 2 little marks, but the question is, well, which way round do I divide it? So take out the giant numbers for a second and just think, well, the Earth's bigger. They want to know how many times the moon goes into the Earth. Simplify the language down a little bit. Right, I'm now back at 2013 and I've got a couple more to do and I'm just going to fly through these ones. If you're still watching, well done. Right, a snail crawls 3 kilometres in 16 days. What is the average speed of the snail in metres per second? So speed. Right, I'm going to start my formula for speed. So DST. Right, well, speed is distance over time. So it's my distance over time. So my distance is 3 kilometres. Hold up. Kilometres in metres. I'm not going to use 3 kilometres. I'm going to use 3,000 for my distance. My time is also in seconds. So my 16 days, I need to go turn into seconds. So to do days into seconds, I'm going to do 16 days times 24 to get into hours, times 60 to get into minutes, times 60 to get into seconds. All right, so the number I'll be using on the bottom is 1382,400. Then I'm going to do my divides. So 3,000 divided by that number gives me 0.00217 and so on. Okay, that's enough to get me where I need to go. They've asked for it in scientific notation to 2 significant figures. So scientific notation to 2 significant figures means my decimal point is going to go after the 2. So it'll be 2.1, but the 7 will change the 1, so it's 2.2 times 10. And I've moved my decimal point from here to here, which means it is 3 places. So -3 for a teeny tiny number. And that will be his speed in metres per second. Now, there was other ways to do this, but I personally, whenever I do speed distance time, I want to do the units they're asking for first. So I do the conversions first. You could do you could do 3 divided by 16 and that'll give you kilometres per days, and then you have to play about and change loads of stuff. This is the simplest way to do this one. And I think the problems came in with the unit conversions and not reading the question properly. Okay, in 2009, we're going really far back now, they started having, whereas in National 5 they did it every year, back at Intermediate 2 and Credit it sometimes skipped a year. So in this one it tells us the weight of an atom of gold, and they want to know how many atoms will be in 1 kilogram. So we are told that 1 atom weighs 3.28 grams. So I'm going to write that 3.27 times 10 to minus 22, absolutely teeny tiny number, is equivalent to 1 atom. We want to know how many atoms are in a kilogram. So we have a kilogram, let's turn it to grams, is 1,000 grams. That's what we want to know what that's equal. So we are seeing how many atoms fit in 1,000 grams. So the sum is 1,000 divided by this teeny tiny number. And this will give us, if I type it in, so 1,000 divided with 3.27, that button, -22. Remember, you can use your negative button or your takeaway button. And to scientific notation, I get this really big long number again. And then it says times 10 to the power 24. So I'm not writing the full thing out. To 2 significant figures would be using the 3 and the 0. So that would become 3.1 because of the 5 times 10 to the negative, not negative, I'm making that up, to the power 24. So that is how many atoms they would be in a kilogram. All right. So again, it's the wording of that one. We know it's a divide, but which way round is it? We're seeing how many atoms fit in a kilogram. So it's a kilogram divided by the weight of an atom. Right, my last question. No, I tell you, it's my second last question. If you're still watching, well done. Orbit of a planet around a star is circular. The radius of the orbit is this. So they have told us what the radius is. We have to calculate the circumference. So good old C equals pi d. So for this one, we just have to do pi times our diameter. Now that's our radius. So rather than actually doubling it, I'm just going to write that we are doing this times 2, doubled, okay? And that will save us having to put extra writing in. So we're just doing pi times 4.96, the button 7, times 2. And it gives me, again, a big ugly number. I'm just going to write it down to show you the rounding of it. Oh, there's no scientific notation appeared in my calculator this time. So I have this. So with no mention of rounding, I've told you I do 2 decimal places. So this will be 3.12 times 10 to the power. Let's see how many places I'm moving it. I'm moving it 3, 6, I'm moving it 8. So for some reason we're counting threes when I'm going backwards like this. So I said that was moving 3, 6, 8. So that would be the power 8. And we are talking about circumference, which is a length. So units would be kilometres. So here we're bringing in another S2 topic of circumference. You should remember the formula from when you're doing your arcs and sectors as well. Pi d goes at the end. If you accidentally did pi r squared, you would drop a mark as long as you did the calculations correctly. And my last one for you is a wee substitution into formula. We all know the formula E equals mc squared, or we've heard of it before. So this one is just asking you to do a really difficult typing into your calculator. So we have to do E equals, and it will be 3.6 times 10 to the negative 2 times 3 times 10 to the power 8. And I'm going to put a bracket around this and square it. Now you have multiple options here. You could go to your calculator and type it all in one go. You could try and square this number. We could use laws of indices. And if you've got a power raised to power, this is going to be 3 times 10 to the power 16. And you could use that. So as I said, you could work out what the bit squared is and then make it easier to type in. But I am just going to type it in, and I'm going to use the bracket around the second one. So I've got 3.6, the button, negative 2, times bracket 3, the button 8, close my bracket, square it, and it puts it into scientific notation for me because it's so big, and it gives me this number here. And I think the difficulty with the question this year was not knowing how to type it in. So as I said, you could work out what this bit is and do times, and basically this, if you were to work out what that is squared, you could do times 10 to 9 times 10 to the power 16, which is what you get when you square that number. So you could do m times that. But I am done. I have done possibly 12 years worth of papers there for you. So hopefully it's helped. Thanks for watching. Bye bye.